Our next speaker has never spoken before, so let's give him a good hearty heckling when he comes out here. All right? He won his 6th grade spelling bee before he was fluent in English. Yeah. Please welcome Chang.
Hello, everyone. I was talking to Jared about my fun fact, and I realized I've never done a single thing to dispel stereotypes in my life. OK, cool. Hello, everyone. I'm excited to be here. This is my first talk, but I've been sort of in the data community for a long time. Today, I'm really excited to be here to talk to you about managing multimodal AI data with Rust. So really quickly about myself, I'm the CEO and co-founder of LandsDB, which is a new database for multimodal AI. I've been making data tooling for about 2 decades, started out my career as a quant, reading Andrew Gelman, and then I got involved in pandas back in 2012 during the Wickham-McKinney war years, and then I went on to do big data in Cloudera, then recommender systems, and now I'm doing quote-unquote AI. So this talk is neither about R nor it's about stats. So am I here? Did I wander into the wrong conference just because Rust starts with the letter R? Well, maybe. But I think in my experience, in the last 20 years making data tools, whether it's about stats or machine learning, about AI, whether you're in R or Python or other languages, a lot of times it all comes down to data, and it's still true today. But I think some things are very different, and Rust gives us an opportunity to create something new and more compelling. To be clear, Rust is not designed to be a replacement for Python or R, but it's designed to kind of change the tooling that we have under the hood. To a large extent, this is already happening in Python. And how many of you are like fluent in Python or written Python before or know Python? OK, all right. So you probably already know a lot of things that's happening here. Rust gives us a much better Pareto frontier in that trade-off between performance and safety, which is why a lot of folks are gravitating towards Rust to make new tools for data. And there's also an opportunity for us to make new tools for new data types. So if you look at AI, data is much more multimodal than before. So instead of just purely tabular data, you now have embeddings, images, audio, video. And how many of you saw the OpenAI announcement last week? OK. Yeah, so I think we all have 5 senses, and AI is going to just become more and more multimodal to suit. And in order to create that multimodal AI, you need to be able to deal with massive scale multimodal data. And then, of course, not just the data, but use cases and domains are also expanding. So I think what we see is a platform shift. So for R and Python users and tool makers for data scientists, it's a great opportunity to rethink a lot of foundational tooling for what we do on a daily basis. Right? So, like I said, this is already happening in Python. I think last year, 2 of the most viewed talks at PyCon US was on polars and pedantic, both based on Rust. And a lot of tools in Python are now being remade in Rust as we speak. So why Rust? I've got about 20 minutes in this talk, and so maybe the rest of this talk will go about as fast as Rust. So number 1 reason why I use Rust is it's really fast. You get C++ level performance in data. And if you don't believe me, here's SpongeBob to convince you, right? And so we're used to R and Python, interpreted languages. A lot of times we complain a lot about how slow some of these things are. We spend a lot of time, or some of us will spend a lot of time writing Python or using Numba and all those things to try to speed things up. But by and large, interpreted languages tend to be a little slower. So for us who are used to sort of Python speeds, Rust performance feels a little bit magical. The same for loop written in Rust is way faster. And you can see when Pydantic rewrote in version 2 in Rust, they saw anywhere between, I think the stated performance numbers were like 5 to 50x faster than version 1. If you guys have seen, have you guys all used polars? And like a fair bit of you. I was one of the original contributors, pandas, but it's really exciting to see kind of polars being this new data frame that's written in Rust very natively and being extremely fast. And then other tooling in Python is also changing, like rough and UV and a bunch of other things. What's more interesting about Rust is not only do you get that performance, you also get C++ performance without all the headaches. And so it's a lot safer. And it does that by making it much harder to screw up the code and screw up memory access in particular. So compared to, say, Python, you have static typing so that the compiler catches a lot more mistakes. Compared to C++, you have the borrow checker, which for beginners in Rust, that can be a little bit frustrating. But once you've sort of passed that learning curve, that hump, it prevents you from making a lot of memory access errors that you could otherwise do in C++. So both of those things make it a lot easier for us to create better and safer programs in Rust. And with safety, it means productivity, so that you can feel more confident about releasing quickly and doing rapid prototypes and creating new tools much faster than you would writing raw C++ for most of us. And so when we started working on Lance, so Lance format is a new columnar format. This is essentially a replacement for Parquet for unstructured data. Right? And we started out writing it in C++. We spent about 5 months before we decided to rewrite it and re-implement it in Rust. And we were also learning Rust as we go along, and it took us about 3 weeks to rewrite that 5 months of C++ code. And if you don't believe me, sort of in early 2023, this is where we started the Rust rewrite. And so this is a chart of our GitHub star history. And the irony of assigning causation to this at a stats meetup is not lost on me. But it definitely, for us, I think it definitely meant that we were not just able to rewrite it quickly, but we were able to ship a lot faster, new features a lot faster after that. The tooling also matters. So, packaging, profiling, et cetera, it makes a huge difference in productivity in addition to safety. So in Rust, you have, crates.io, kind of like CRAN, and much better than PyPI, I think. And docs.rs is great as well. And now Rust also has very good benchmarking and profiling tools that you might be used to in C++, but it's very easy to set up in Rust. And probably, at least for me personally, the biggest benefit is I don't have to wrestle with CMake anymore, which is probably sort of on par with the safety of Rust as a productivity improvement. And the last thing about Rust is the community. The Rust community tends to be very, very open and inclusive, and it's really helpful. I'm a big, strong believer in community over code. And the data community in Rust is a little bit newer, right? So Rust started out in sort of system programming, and then there were a bunch of Web3 folks that got into Rust that was focusing around web apps and async and things like that. And the data community in Rust has been growing in the past 3 to 5 years, I would say, and it's growing really fast. So when the community is open and inclusive like this, it creates this sustainable growth for tool makers in data science and data engineering. And one of the great things about the language being relatively newer is that there's not as much baggage, and there's a lot of still meaningful evolution that is delivering new and meaningful features for the community. Right. I think these things answer why Rust. And the big thing about why Rust now is I think the ecosystem has grown a lot for data in Rust just in the past couple of years. And to repeat my statement earlier, Rust is not designed to be the data scientist language. It's the tool maker language. Obviously there are tons of data scientists who would be interested and are writing Rust, but by and large, we're still writing on Python, and the idea is that we would write Rust and create tools for data science. And so in Rust, now you have PyO3, NAPI, and Extender, which allows you to write one piece of code in Rust, and then with a little bit of boilerplate, you can run it in Python, you can run it in JavaScript, you can run it in R. And one of the big things that's interesting about AI is that it's actually bringing a lot of the JavaScript community into the data community as well. So not only can you run the code across languages and across platforms, you also need a way to exchange data. And so if you have to deserialize and serialize data whenever you cross language boundaries and make copies and everything, that gets really slow. And so one of the critical things that enablers for this Rust-based ecosystem is the maturity of Arrow, especially in Rust, so that you can have data being generated in your Rust package, and then without having to copy it, you can use PyO3 or Extender or an API to essentially bridge that gap and into other languages, so that it stays very fast and you keep your performance gains. And then, of course, with the Arrow Rust crate, there's also a project, there's also a crate called Object Store, so that you can unify storage access so that your data can live on a local file system, in S3, in GCS, any object store, and you can target it using essentially the same code, which is hugely convenient. All right, so why Rust? And why Rust now? Performance, safety, great tooling, great community, and a data ecosystem that's gotten a lot much more mature, right? And so, if you didn't catch any of the details, here's SpongeBob again to convince you. All right, so of course, Rust is not designed to be a replacement for all languages. So why not Rust, right? Rust is not a good fit for a bunch of things. Right, it's not good for directly data scientist user-facing libraries. The type system and a lot of the language features and borrow checkers are, there is a learning curve, and it's not really, and it shouldn't be an integral part of what you do every day as a data scientist. So that's why we focus a lot on these like Rust and Python or Rust R interop things. Applications where performance and safety memory safety matters less, especially if these are legacy applications written in a different language. So if there's no sort of pot of gold at the end of the rainbow, then there's less motivation for you to actually go through the process of learning Rust and rewriting the application if at the end of the day that performance doesn't end up mattering. And then for web applications, I think Rust is still better than like Python, C, C++ in terms of concurrency and async and things like that. It's just not quite as good as Go, for example, that's specifically written for these types of things. All right. Cool. So, I'm not sure. OK, there we go. So talk about Rust and generically, what are we doing with Rust? So we're trying to create new data infrastructure for multimodal AI. And our tagline at LanceDB is that we Lance a lot. So we know that, so I said earlier, that's still all about the data. But this time, AI is still a little bit different. And it's not just about the fact that we have GPUs now. But if you look across sort of this typical cycle of model training and serving, from exploration to training to evaluation to serving, you now have a lot more variety of data, from tensors to log files to the raw images and videos and things like that. And they're a lot harder to deal with. And the workloads are a little bit different too. So you have all of these unstructured data and including embeddings for search and retrieval. And then what that means for traditional tabular data infrastructure that was sort of laid down like 10 years ago is that they can't satisfy all the requirements for AI. So you need things like fast scans to do analytics. You need a fast random access, which Parquet doesn't do, for search. And then you need you need the first two, but also be able to deal with large blobs for training and storing all that unstructured data. And so if you kind of lay out the different data infrastructure or formats, you'll find that each one is good for at most two, but most of the time is only good for one of those three, and you need all three. So I call this sort of the CAP theorem for AI data. And the consequence of this problem is that AI teams are essentially creating many single task systems and stitching them together in this Rube Goldberg kind of machine. So you've got like a data lake, traditional data lake with your Parquet data, and then to do search, you have to load it into a vector database. To do training, you load it into your training data infra, and you have to convert it into like tensors or something like that. And then when the results come out, then you have a separate eval warehouse where you're running maybe BigQuery or Trino, and you have to maintain these separately. You have to keep them all in sync. So it's really expensive. It's way too complex. And I think, to me, the worst thing about this problem is that your highest paid employees are doing menial data tasks way too much rather than focusing on the modeling. So at LandCB, we asked, OK, what if we actually can have it all? So rather than this being limited by this CAP theorem, what if we can have our cake and eat it too and try to address all three? And that's what we've done with Land's format. It is designed to be a new columnar standard for unstructured data that's optimized for AI. And well, our original implementation was in C++, but we've since rewritten it in Rust. And the performance has been really good. So compared to Parquet for a lot of AI use cases, you see something like 10 to 100x speed ups for things like search and training, data loading, and things like that. And so what this allows us to do is essentially move from this like Rube Goldberg-like system to a much simpler system where it's one table that is your single source of truth that can hold all the different varieties of data that you have and can be the basis for all the different query workloads that you have. So if you look on the left two columns, you can run SQL on Lance data for traditional analytics and selection. On the text and tensor and in binary data, you can load it into our PyTorch data loaders to do training. And then if you have embedding data, Lance format also comes with an indexing subsystem so that we can do sort of billion scale vector search in milliseconds, and all within the same package. So around this, we're building LandCB, right, which we're calling it developer-friendly, open-source, multimodal database for AI. Today, it's being used by generative AI companies like Midjourney and Character AI, and also by tech companies building AI features like Airtable and Hex. So it's developer-friendly because it's embedded, think SQLite, but for vector search, right? So you just do pip install LandCB. You don't have to manage any extra infrastructure. And then you can serve it directly. You can serve your data directly from S3. So really, it simplifies your production AI infrastructure a lot. It's also hyper-scalable. So we have LandCB Enterprise, which can serve billions of vectors in production with low latency and extremely high QPS. And it gives you this ability to separate compute from storage so that the infrastructure costs are an order of magnitude lower than vector databases that you see on the market today. And the last thing is LandCB is the only multimodal database out there. So it's one system that can serve vector search, full text search, and also your images and videos, retrieval, and everything in between. And then you can do exploratory data analysis on this, search and retrieval. You can run analytics workloads, and also you can extract the data for training workloads, and have it all in one piece of data without extra copies and things like that. All right, so I had a little demo about Hogwarts, but I think I'm running out of time, so I'm going to save that for the break. If you guys are interested, come find me. And if you're interested in AI or Rust, please join our Discord and check us out on GitHub. And we are hiring full stack and database engineers if any of you fit that profile in the audience. All right, thank you.